Today's exercises include exponent rules in them, or also called exponent formulas. They are connected with trigonometric functions, and they're again actually proved using the main trigonometric identities, which we already know. So the formulas that we'll be using today are the exponent formulas, and here are them. The first is with sinus squared alpha and cosine squared alpha, but we also have sinus squared alpha divided by 2 and cosine squared alpha divided by 2. Those are their values, which we'll be substituting in the exercises. So if you don't know them, learn them, and then come back in this video and try to solve the exercise which we'll be solving today. Today actually we'll solve two exercises, not only one. The one is with squared sinuses, and the second one will be with squared cosines. So let's start. If you don't know the formula, you can just use the ready formulas and use them from here and only substitute the values. So today I'll choose a different color. For example, I want something with green. Let's try with green. So our identity is sinus squared alpha plus sinus squared beta minus sinus squared gamma is equal to 2 times sinus alpha times sinus beta times cosine gamma. Don't forget that we are working in a triangle. That means that when we have two angles, not true. When we're having three angles, alpha plus beta plus gamma, and we add them, they should add to 180 degree. Or for example, if you want to present one of the angles, we should subtract the other two ones from 180 degrees. So for example, alpha is equal to 180 minus beta plus gamma, or beta is equal to 180 degree minus alpha plus gamma, or gamma is equal to 180 degree minus alpha plus beta. Also, if you want to present alpha plus beta, you can subtract the third angle. If you want to present two angles, you subtract the third angle from 180 degree, or if you want alpha plus gamma, you subtract beta from 180 degree, or if you want gamma plus beta, you subtract alpha plus 180 degree. So those are the properties in triangle that we are using in our exercises, and most of them are really simple. They're the basic properties, so we learn them, for example, in third grade or in third grade, but for example, fifth grade or fourth grade, and we should know them. Yeah, they're just formulas that are proved through the triangle rules. Yeah, and now that we're having this, let's name our first identity A and our second identity B. Yeah, that's how we are going to code them. So we're having we will solve independently only identity A, and we're going to prove that it's absolutely equal to identity B. So start with this. Now we are having sinus squared alpha, sinus squared beta, and sinus squared gamma. You know that all of the formulas for exponents are with a denominator 2. So the thing that we'll be using is the thing that we've done is to put everything under a common denominator of 2, because we're having only full angles, not half angles or something like that, for example, to obtain 4 or even a greater value for the denominator. So we're having 2. And now we're looking at the first, sinus square alpha. You know that sinus square alpha is equal to 1 minus cosine 2 times cosine 2 alpha divided by 2. We have this divided by 2, so we're having only 1 minus cosine, 1 minus cosine 2 times alpha, and we're putting it in bracket. We don't need actually to put this in brackets because it's the first term, but no matter. Okay, sine 2 beta is equal to 1 minus cosine 2 times beta. It will be equal to this. And then for the third term, we'll be having minus 1 minus cosine 2 times gamma. Yeah? And now Now let's release the brackets, yeah? This will give us 1 minus cosine 2 times alpha plus 1 minus cosine 2 times beta minus 1 plus cosine 2 times gamma divided by 2. So we subtract the ones, they cancel out, and we have only one remain. So what we're having is 1 minus cosine 2 alpha minus cosine 2 beta plus cosine 2 gamma. We can sorry. Yeah. What we can do is to factor out a minus sign in front of a brackets. So 1 minus, and inside the brackets cosine 2 alpha plus cosine 2 beta. Yeah. And then plus cosine 2 gamma. And in the brackets we will obtain an identity. Yeah. And this is a formula for addition of two trigonometric functions. So we just apply the formula and we obtain a is equal to 1 minus, in brackets, 2 times cosine 2 alpha plus 2 beta divided by 2 times cosine of 2 alpha minus 2 beta divided by 2. And then plus cosine 2 gamma. A will be equal to 1 minus 2 times cosine alpha plus beta we will obtain, or let me write it like that: 2 times alpha plus beta divided by 2, so it's clear for people who will solve this exercise for the first time. We just factor the 2 in front of a brackets to be easier to substitute. Yeah, not to substitute, but to cancel factors. Yeah, and we're now having a is equal to 1 minus sorry. Yeah, we will, yeah, 2 times cosine. We just simplify them. Yeah, we reduce the number 2 from the numerator and the denominator, and we are only obtaining cosine alpha plus beta. The same here, we are just simplifying, and we obtain alpha minus beta, and the whole thing plus cosine to gamma. Now we are having this minus 2 times cosine, not cosine, but yeah. But before releasing the brackets, do not release them. Yeah, we have alpha plus beta. We know that alpha plus beta is 180 minus gamma times cosine alpha minus beta, and plus cosine 2 times gamma. A is equal to minus 2 times, a cosine of 180 degrees minus alpha is equal to cosine of alpha. Yeah, this is again like a main. It's not like an identity, but yeah, it's not identity, but it is. I don't know how to call it, but sorry for the mistake. It's equal to minus cosine of alpha. Yeah, minus. Yeah, so we are using 2 and then minus cosine and then gamma. Yeah, minus cosine of gamma. So the same with the sine. Sine of 180 degree minus alpha is equal to minus sinus alpha. Yeah, and we can use this in our identity, just actually to solve it. Um, yeah, I got confused. I don't know why, but yeah, I got confused. Sorry for the mistake. It's not like that. It's not like that. Let me write the formulas correctly. Yeah, so the formulas are sinus of 180 degree minus alpha is equal to sinus alpha, not with minus sign, because sine is an odd function, and cosine of 180 degrees minus alpha is equal to minus cosine alpha, because cosine is an even function. Yeah, the same with tangent and cotangent. They are 180 degrees minus alpha. They're minus cotangent. And tangent of 180 degrees minus alpha is equal to minus tangent. So those are important ones, so make sure you remember them. And now let's substitute here. We're having times cosine alpha minus beta plus cosine square gamma. Now we have minus here and minus here. Here is multiplication, so we only obtain plus. Yeah, and we are having plus 1, here plus 1, because we removed the 1. I don't know why. We didn't write it here. So A is equal to 2 times cosine gamma, yeah, 2 times cosine gamma times cosine alpha minus beta plus 1 plus cosine square gamma. Now, what we can use from here, this is actually one of the main things that we can use, and this is the most important, the most important one. Yeah, we're using the cosine square gamma. This is a formula for exponents. We're using it 2 times cosine gamma times cosine alpha minus beta plus 1 plus cosine square something is equal to 1 plus cosine 2 times divided by 2. Yeah, but because it is divided by 2, yeah, it is divided by 2. That's why uh that's why I forgot what I was about to say. But yeah, I forgot what I was about to say. No. Sorry guys. It's not to the power of 2 here. It's 2 times gamma, yeah? 2 times gamma. It's not to the power of 2. So we are having 2 times gamma. So this is equal to 1 minus, actually, this is equal to, yeah, cosine 2 gamma, or for example, cosine 2 alpha is equal to 2 times cosine square alpha minus 1. And we'll be using the same for gamma. So 2 times cosine squared gamma minus 1. And then we substitute this once, they cancel out. And we have A is equal to 2 times cosine gamma times cosine alpha minus beta plus 2 times cosine squared gamma. And now we're having a common factor, 2 times cosine gamma, yeah? So 2 times cosine gamma times cosine alpha minus beta in brackets plus one more time cosine gamma. Yeah? And now we are having the same situation as in the previous exercises which we've solved. We're having cosine of alpha minus beta plus cosine gamma will present it as just simply we can present it as, for example, you know, because we're having these things, we can present it simply as 180 degree minus alpha plus beta. But because we don't have the denominator 2, it will be easier for us if we present it in another way. And the other way to present it actually is like that. Cosine alpha, yeah, to be presented as, alpha, yeah, is equal to, not alpha, but alpha plus gamma is equal to 180 degree minus beta, yeah? We're having this. So, uh, sorry. I'm sorry about this exercise. I don't know why I'm confused and why I'm actually distracted from the exercises, but yeah, I forgot my thought, and that's why everything happened. So cosine alpha minus beta plus cosine gamma, and now we are directly apply the formula without converting cosine gamma into 180 minus alpha plus beta, because we don't have something here. We don't have, for example, parameter 2 to subtract and obtain a sinus value. So we'll be only using cosine plus cosine formula, and cosine alpha minus beta plus gamma and divided by 2 plus, not plus, but times cosine alpha minus beta minus gamma divided by 2. And that's what we'll be using. And A is equal to 2 times cosine gamma divided by cosine of, you'll see what. Now we're having, let's look at the additions. For example, gamma plus alpha is equal to 180 degrees minus beta. So on the first thing, we will be obtaining 180 degrees minus beta, and here we remain one beta more, and divided by the whole thing divided by 2. Yeah, and here we have cosine. We have, let me see. What we have here is alpha plus beta. Because we'll be having, actually, sorry for that, but yeah, we'll be having the first one subtracted from the second because it will be easier. I got confused, guys, what I was about to do. Okay, let's put this alpha minus beta plus gamma. Yeah, divided by 2. And what we'll be obtaining, 2 times cosine gamma times cosine of 108 degree minus 2 times beta divided by 2 times cosine alpha minus 180 degrees minus alpha. Yeah, because beta plus gamma is equal to 180 degrees by alpha. We divide by 2, and A is equal to 2 times cosine gamma times cosine of 180 divided by 2 is 90 degrees, and minus 2 beta divided by 2 is minus beta, and times cosine of here 2 times alpha minus 180 degrees divided by 2. So we obtain A is equal to 2 times cosine gamma times sinus beta, because you know cosine 90 degrees minus beta is equal to sinus beta times sinus of alpha minus 90 degrees cosine. You know, we have cosine here. Cosine of alpha minus 90 degrees, because we know that cosine is an even function. Yeah, cosine is even function. Therefore, cosine of alpha minus 90 degrees, for example, is equal to cosine of 90 degrees minus alpha, and is the same. Therefore, cosine of 90 degrees minus alpha, you know that this is equal to sinus alpha. So we're having the same here. We can simply write it as A is equal to 2 times cosine gamma times sinus beta times cosine of 90 degrees minus alpha. A is equal to 2 times cosine gamma times sinus beta times sinus alpha. And when we order them, 2 times sinus alpha times sinus beta times cosine gamma. So let's check the B. Let's check identity B. When we check it, we have 2 sine alpha times sinus beta times cosine gamma, which is the same with what we obtained. Therefore, identity A is equal to identity B. Moving forward to the next identity, and this is cosine squared alpha plus cosine squared beta minus cosine squared gamma is equal to 1 minus 2 times sinus alpha times sinus beta times cosine gamma. You know, it's the same, but here identity A consists only of sciences of cosines. Moving on to the next identity, and this is cosine squared alpha plus cosine squared beta minus cosine squared gamma is equal to 1 minus 2 times sinus alpha times sinus beta times cosine gamma. You know, here identity A is the same, but our functions are cosine and they are not sine. Again, remember we are using the formulas for exponents, and also we are using that we are working in triangle. So the angles add up to 180 degrees. Also, we can represent the angles. And yeah. So starting off with expression A, we're solving it again independently. A is equal to cosine square alpha plus cosine square beta minus cosine square gamma. And yeah, we're applying the formula, putting under a common denominator and then using 1 plus cosine 2 times alpha plus 1 plus cosine 2 times beta minus 1 plus cosine 2 times gamma. A is equal to 1 plus cosine square gamma, not square but 2, plus 1 plus cosine 2 times beta minus 1 minus cosine 2 times gamma divided by 2. Now these two ones cancel out and we're having 1 plus cosine squared alpha, not square, plus cosine 2 times beta. I don't know what I'm saying square. They're not square, they're double angles divided by 2. Now we're having 1 minus cosine 2 times gamma plus, this is the formula for sum of trigonometric functions, so we're just substituting 2 times cosine 2 alpha plus 2 beta divided by 2 times cosine 2 alpha minus 2 beta divided by 2. And yeah, now going back, A is equal to 1 minus cosine 2 gamma plus 2 times cosine only alpha plus beta we will obtain times cosine alpha minus beta. And also the whole thing divided by 2. Don't forget the denominators. A is equal to, now let's present this 1 minus cosine 2 gamma. We know that cosine 2 gamma is equal to 1 minus 2 times sinus square gamma. And if we solve for sinus, we will obtain minus 2 times sinus square gamma is equal to cosine 2 times gamma minus 1. Dividing by minus 1, we obtain 2 times sinus square gamma is equal to 1 minus cosine 2 times gamma. So our part of the expression 1 minus cosine 2 gamma is equal to 2 times sinus square gamma. So A is equal to 2 times sinus square gamma plus 2 times cosine alpha plus beta times cosine alpha minus beta divided by 2. And here we see that we can simplify. Here we have 2, here we have 2, here we have 2. So we can just simplify the denominator. But before that, let's present this sinus square alpha as 2 times 1 minus cosine square alpha. We're using the basic trigonometric identity, yeah? Sinus square alpha is equal to 1 minus cosine square alpha. This is the main trigonometric identity divided by 2 and plus 2 times cosine alpha plus beta times cosine alpha minus beta. So we are substituting, not substituting, but we are subtracting the, we are just simplifying the expression. We remove the denominator and we obtain only 1 minus cosine squared gamma plus cosine of 180 degrees minus gamma times cosine of alpha minus beta. So A is equal to 1 minus cosine squared gamma plus cosine plus, but it will become minus. We have here, we obtain minus cosine gamma. So here the plus is substituted by minus cosine gamma times cosine of alpha minus beta. So the common multiple here is cosine gamma, and we put it under a bracket, before a bracket, 1 minus cosine gamma times times cosine of alpha minus beta plus cosine gamma it will become, because here plus and minus, it will become minus, and it will become minus cosine squared alpha. This is our term, so it should be plus in the brackets. A is equal to 1 minus cosine gamma, and in the brackets we are doing again the formulas, the addition formulas of the trigonometric functions. Of course, you know that here we don't substitute the value of gamma with 180 degrees minus alpha plus beta, because it's not okay. And it is not okay because here we don't have something to simplify. So we would rather prefer to just write it as like that, and then, for example, then present two of the angles as something else. Here we'll subtract gamma from alpha minus beta, because it will be easier, divided by 2. Now we are having A is equal to 1 minus cosine gamma times cosine, here alpha plus gamma is equal to 180 minus beta, and one more beta minus beta is equal to 180 degrees minus 2 times beta, and this whole thing divided by 2, we obtain cosine of 90 degrees minus beta, and here cosine of alpha minus alpha plus beta divided by 2. Alpha plus beta is equal to 180 degrees minus alpha, and minus this alpha we have 180 degrees minus 2 alpha, and the whole thing divided by 2 we have 90 minus alpha. So simply we have cosine of 90 degrees minus alpha, and here we have A is equal to 1 minus cosine gamma times sinus beta times sinus alpha. And when we reconstruct the expression, here we should have 1, 2, we forgot the 2 here from the formula. We just have A is equal to 1 minus cosine gamma times 2 times sinus beta times sinus alpha, and when we rearrange the terms, 2 times sinus alpha times sinus beta times cosine gamma is equal to A. We go back to B, and we see that B is equal to 1 minus 2 sine alpha times sine beta times cosine alpha times cosine gamma, and we're having 1 minus 2 times sinus alpha times sinus beta times cosine gamma. So we proved that A is equal to B, and the exercise is solved.